vascularization like this, increased vascularization. For plexuses to the skin, the subcapillary plexus. So look at this picture and kind of visualize that there's a kind of an outermost chunk of vasculature and then an innermost layer. So the subcapillary is more outermost, so between the capillary and reticular dermal layers, and will really be supplying that epithelium very much. And then the deep dermal will be closer to the base of the dermis, or that interface between what lies beneath the subcutaneous layer, which is going to be very rich in adipose tissue. And so that really supplies very much the dermal layer. So the subcapillary plexus is very much going to be the source of nutrient and oxygen to epidermal tissue, or to keratinocytes. Then there will be a lot of anastomosis between, so that you can very quickly meet needs, shunting blood toward or away from that outermost plexus for whatever thing, for temperature increase, more blood for particular activity, or outer for cooling. So when the body is able to, you want to dissipate heat, you want a little more blood shunted outward, so that the ambient temperature can help regulate some of that blood. So that's cute that you have those two plexuses, so that blood can really be very quickly moved away or toward a particular area. The subcutaneous layer, so below the dermis, loosely anchoring skin to underlying muscle, very fatty. And so this is really where you get this epidermis dermis being able to float or move across because of that subcutaneous tissue. So this is where you're going to be putting sub-Q injections in. So going through those layers and into that fatty layer, and it really creates a deposition of material that can then be absorbed into probably largely the dermal plexus, but to both sides. Very vascular area. So you see that on this picture now. You can see epidermis going away, dermis, and then the subcutaneous, very fatty layer. So the dermis, you see, is quite thick and full of a lot of stuff. So of the appendages and glands and receptors. So we'll go to those. Oh, I like this summary. I just love a summary table. I love a table. So there's one for you. Just putting what is all there and laying it all out. And then a picture of skin, but bigger. So you can see all these bits. The two plexuses you can really visualize there. AV shunts in between. But what we notice is this epidermal surface and then hair and nails. We really pay a lot of attention to that stuff because that's what we see and that's what we use and it's what you see on yourself. You don't see your own eyes or face. And until there were mirrors or an ability to see your own reflection, all anyone really ever saw were the skin from here down, you know, and that was who they were then and what they could do. So I think that's kind of an interesting social thought, is that now we see ourselves, and oh gosh, don't we? So the hair is there, but then also all of the receptors, you can see very well. Sensory receptors. Merkel cells. These are really interesting because it's just a cell that has a close association with a sensory neuron. And so you see that Merkel cell, and then you see the sensory neuron sitting separately. So that's kind of cute. But look at this distribution. It's just a cartoon, but I think I love these kind of simplistic pictures because my little brain needs things really broken down simply. But you see epidermis, and so all of this sensory information is going to be coming from the dermal layer, but how do you attach that to the epidermis, really? So it's cute that you have this little epidermal cell, which is a Merkel cell, sitting in the epidermis within toward this papillary kind of layer. And then the sensory neuron just kind of coming up right to it. So I think that's just an interesting little combo pack there. Light, sustained touch, and pressure. Think of all the different ways you are able to sense something and then stop sensing it, that you're not completely aware of your clothes. You're aware of your bra. I'm sorry, Paul. I'm not sorry. But you're aware of your clothing. You're not aware, you habituate to certain things. And then, so it's just, when you think about all these different sensations, because when neurologically you're studying that, and you know that there was light, touch, and pain, and there are different columns, and so you sense all that, and vibration, the vibratory sense from light to heavier, and then how close can you discriminate points. So we have something for all of those, and it's all seems kind of similar and runs together a bit, but Merkel cells are going to be for that kind of that sustained sort of pressure, so less of a sudden pressure. And it really goes to what stimulates them and how rapidly do they deflect and send that information. How do they depolarize and send that information to the sensory neuron, and the speed at which they do that. And for a lot of these, they degrade over lifetime. There are free nerve endings, which I call raw nerve endings. So there are some of those where just the nerve itself can be stimulated by changes, molecular changes in the tissue around it will stimulate sensory information. So you have to assume that chemicals themselves that are in the skin or surrounding surfaces will naturally have a response with sensory nerve. The root hair plexus, there is a plexus of nerve endings around the root of the hair follicle, and that's how we know that the wind is blowing and stuff like that. Movement against the hair is informative, and you're very, that's those sensations of the hair movement itself. And so, gosh, do you ever get a scalp massage when you go get your hair done? Again, Paul, sorry. Does he or she just, that is so, God, is there anything more intimate than a scalp massage? Whoever touches your scalp, there's no doctor for that. Is there really? I mean, there's no, that's a very, when you think about scalp manipulation, is very rare. So I was something on facial or something, and she said, do you want a scalp massage? I'm like, I will not say no to that, ever, under any circumstances. Well, I suppose there could be a circumstance that would be really creepy, and just that we don't really have our scalps touched or stimulated ever, and so anyway, that's very, that's a lot of nervous sensation with all those hairs and stuff, so anyway, interesting. Oh, you just decided no one needed to hear that. No one needs to hear that, okay. She's talking about
for us
here. Short time we've had together.
We should have been here last week. We were talking about giving birth and stuff, and at least 3 people walked into our classroom.
I'm like, we don't want to know what they're talking about. I think it's a coven. I love me a Eisner Corpuscle. These things are just awesome. So look at these. They're perpendicular. Now in this case, the cell itself is associated with the sensory neuron directly. So this whole apparatus that is the Eisner Corpuscle will have an afferent and an efferent kind of meandering through it. I use the word meander. And so here's a couple of different electron micrographs that show that. But just the fact that they're perpendicular is interesting too. So you have, various cells aligned in certain directions, and what is going to stimulate that cell? And in this case, really sensitive to very light touch. And this is really these are really dense in certain areas of the skin. But this is where you could get closer and closer to point sensation, less so on the back, more so on the fingertips. It's due to density of these Eisner corpuscles. This is one of those things that there is age-related degeneration for sure on. These corpuscles will degrade in number over time, and so with aging, and that process begins at under the age of 50, and so that by the time people get older, they do lose a lot of that two-point discrimination. And so that's just, I think, an important way to just realize that. It makes sense. You have to suss out, is there from a neurological standpoint, is there something asymmetrical about this, which could prove to be something a little more acute, or is there a kind of an age-related symmetrical loss while you're trying to determine these things? So, you just have less of stuff as you get older, less activity of these cells. But these cells actually decrease in number. So anyway, they're very interesting. They're rapidly adapting so that you're not aware, again, like of something like constant wind blowing kind of thing, or some sort of constant sensation. You can adapt to that and habituate. Or if there's a sudden pressure change or touch change, you're very aware of that. So that rapidity of generating action potential or habituating to that. These are gorgeous. These are just gorgeous, lamellated Epithelial corpuscles. Really layer and layer of something Schwann cell. Maybe it's not exactly a Schwann cell, but that thing where the cell wraps and creates all of that big insulating, sort of dense and bilayer, membranous material, lipid bilayer. And you have all of that, and at the core of it, a single afferent sensory neuron. So surrounded by all this insulation. And so what would it take to get to that? And so it's really going to be sudden pressure changes, something very acute. Isn't it lovely how all these things are arranged and they create the milieu that we have of sensation and texture and ignoring sensation? So anyway, vibration sense very much about Epithelial corpuscles, and I just think that's so elegant, the interrelationship of where is that neuron and what's going to stimulate that thing. So we don't want, in this case, really small changes to be felt. We want to be very aware of pressure and vibration. Vibration sense really is touch or sensation. It really is vibration very much. Different than a placing and a pressure, something that's going to be suddenly felt that would get all the way into the core of that corpuscle. So we have all these different ways of getting at that. And then there are the Ruffini corpuscles, which are really very firmly attached to connective tissue, and they will note that torsion or twist. Did kids do that thing? Ugh, I hate that kind of thing, that thing. That torsion or twist of skin has to be sensed as well. And so that's part of the Ruffini corpuscle. Glands, sebaceous glands. Epithelial in nature, really derived from epithelial tissue and invade the dermis layer, embedded in the dermis with pores to the outer surface. So we have a lot of pores. Also, these are attached to hair. And so you'll have just an oily substance, sebum, that will be directly placed on the skin. So that's a good thing. Continues that kind of lubricating, hydrating, waterproofing process that happens. Very much can be tied to kind of puberty and amount of quantifying how much of the activity of these as well. But they're really numerous on face and scalp, oiliness, secreted to hair follicle, or directly to glabrous skin, and that's just hairless skin. So areas where there's fewer hairs will have pores where the oil can be secreted directly. They can be, these ducts can be blocked, and you get whiteheads and acne and so forth. So here's glands. I just don't remember if I've looked this, something like this up before. But the different kinds of secretion, merocrine, apocrine, holocrine. And the thing is that things will be called stuff and they'll have a different kind of secretory process, so it's not really that big of a deal to me. We call them acinous glands because it has this kind of cluster structure. So here's a real typical acinous gland, so that you have something, lots of cells around a duct is an acinar structure. You saw that probably described during, I think, specifically a pancreatic structure, or islet cells and such. So you have these epithelial cells that form the duct, and those cells are called myoepithelial cells, which is to say they have a little bit of contractile function. So that's how you can get secretions from these cells out. That duct, the duct itself can kind of milk the product toward the surface or toward that hair follicle. So in this case, the cells are the sebocytes, produce sebum, they die, and that makes them classically this holocrine secretion type. Sebum itself is just waxy stuff, so triglycerides, wax esters. Squalene is kind of like a fatty acid, really. It's a specific fatty acid, so long chain with double bonds, and then free fatty acids. So, you know, lipid stuff that would create this kind of greasy, waterproof product. It's odorless. Bacteria will produce odor if it's there. Some specialized sebaceous glands. Oh, there's going to be a nipple. The meibomian glands, or the tarsal glands around the eye, and they'll help secrete the, it makes sense that you would have that oily surface that helps the tear stay inside in between the lids and really create that confluent kind of wet surface across the eye. Areolar glands are for lubrication and protection around that nipple, especially important during lactation, because that is the feeding source. This one right there, a feeding source. I'm now going to do an examination on your feeding sources. Don't ever say that. Don't say that. I'm telling myself, don't say that. Sweat glands, sudoriferous glands, that's a good name, isn't it? Sudoriferous. Epidermal invaginations into the dermis, so again, epidermal derivation. They're innervated by the sympathetic nervous system. And there are two types of sweat glands. Eccrine. I had a professor that would call these eccrine, and so I thought, I've always said like eccrine, and I thought, I'm just going to actually look it up, and it's eccrine, but I got over into the YouTube thing where they're trying to pronounce stuff. Have you ever seen that one where they're, oh, have you not? Oh my God. Well, you get lost in that, but it was an actual real one where they were going, eccrine. They said it all the ways you could say it, so it was of no use. They'll put a word on there. There's some guy, someone does this where it might say eccrine, and there's no point in me saying this because I can't even reproduce one, but they'll just say, the word is completely wrong and it's hilarious. So, wow, that's why time on your hands. glands. It says sweat gland is widely distributed. We know about our sweat glands. Our sweat glands and our oil glands. Sweat glands widely distributed, up to 3 million, especially the forehead, palms, and the feet. And so you will certainly learn about the hyperhidrosis, where people are just quite miserable with excessive sweat gland function. 3 liters a day is not abnormal. That's just a lot of damp sweat. Wash your sheets, I'm just saying. With bleach. Thank you. Very excellent point. And if you've used a towel once, or you've worn something once, I'm just saying this because will be a conversation you have in your marriage. Those shoes are really cute. But he'll say, but I only wore it once. Like, but it's been hanging there a week. It didn't get cleaner after you wore it. You know what I mean? Like that you wiped stuff off your body with it, and then it hung there for a week. It's not cleaner now, even though you wore it once. Why am I talking about that? Coiled tubular gland that opens to a sweat pore. Clearly, it's a source of frustration in my house. So here's a cute little sweat gland there. I like the little blue picture you showed there. It secretes sweat, which is conducted to the skin surface. So what is sweat? Mostly water. So it's some electrolytes in it. You know that. Sodium chloride, potassium, some glucose, which is nice. It feeds your normal flora. IgA is in there. Secretory IgA is immunoglobulin A, which is the antibody that we found across skin surfaces. Dermacidin, so some proteins that are antibacterial and so forth for the purposes of evaporative cooling, and then some waste disposal as well. You're going to have some nitrogenous wastes in sweat as well. And then there are myoepithelial cells, which will kind of milk that stuff to the surface. Cute. An apocrine sweat gland. These are specific to really axillary and anogenital regions. They're very much associated with puberty. This is one of those things that we use anti-deodorants, antiperspirants for our apocrine sweat glands. So it's a kind of sweat gland where the product is a little bit more proteinaceous, has a little bit more stuff in there. So a little less watery, maybe just a little more information for other mammals is probably what that's about. Something very kind of very deeply instinctive and mammalian. Your pits. The function of your pits is very mammalian. So there are pheromones and such that is someone crying? It would be a PA student. He's out there. It's an interview. Are they conducting interviews?
Yeah.
I want to help people. I really like people. I thought about being a stewardess, and then I decided that I'll go be a PA and help people. And then you get in here and you're like going, this doesn't feel like helping people. It feels like I might kill people. I remember looking so specifically at Dr. McNeil thinking, I mean, I bought a new suit and you wanted me, you know, I was all shiny and showed you all the stuff and my grades and everything, and we had a conversation, and you let me in, and then you're going to treat me like that? There was, like, you were dating. No, I'm not saying I dated Dr. McNeil. That's whack. Totally different. That's not what I mean, but I mean the program, you know, like you're dating the program, and then you get married. Oh, okay. I see. I see your sweat glands now. So under sex hormone control, and anyway, they're not really an apocrine kind of secretion, they're really actually American secretion. But I remember specifically there were one or two board questions I had on this last boards that specifically had apocrine glands on there somewhere along the way, which is interesting. I don't remember the questions, I just remember how I felt when I read them. Okay, I guess we were supposed to have physiology. It was, something really, the derm questions are derm people are different. Derm people are a little different. They are a little bit, you find every practice has its difference. With the derm people, there's just a lot going on there because a lot of internal information goes to the skin. So I think the derm people is maybe a little more pathophysiological in some ways, which you wouldn't maybe have suspected in the get-go. Some specialized apocrine glands that would not be specifically those in the anogenital region, but ceruminous glands, which are in the ear, that make earwax. They specifically are draining into garden hairs, or the hairs in the canal, and producing cerumen for earwax. And that's a very lipid-like, very thick, waxy anti-water, waterproofing sort of substance. And so people either have kind of that waxy stuff that gets dark, or the flakier stuff. But either way, it is from the ceruminous glands. And then the mammary gland, again, this isn't the same as the areolar glands. This is obviously the milk glands, and they are a specialized apocrine type sweat gland. So certainly under the influence of hormones for their production, the groups form lobules with a duct opening to the nipple for milk production and release. Under the influence of prolactin and oxytocin, as you recall. So back to the bits that are in the skin. So epidermis, dermis, the different kinds of sensory receptors. I think this picture has lots and lots of them. The Eisner Corpuscle, it's a neat thing. There were Merkel discs, I don't know. Those are probably in there. Eisner's corpuscles, free nerve endings, you see that, all the different things. So then a sweat gland, hair follicle, we'll go to that. And then the pores where sebaceous glands may release their substances. So I think it's kind of useful to look at all that stuff and just remember what's in there, where it originates. So most of this stuff you find as part of the dermal layer, with the function being extruded to, or secretion extruded to or through the epidermal layer. Hairs. Hairs are so fascinating. It is an elongated keratinized structure. So think that horny layer, or that outer layer of the skin. If you just took those cells that would then slough off, if you take all that stuff and compact it down into a shaft, you would make something like a hair. And that's exactly really what happens. So in terms of hair products and all that, it's the cuticle that we're trying to really treat. It's that outermost scaly kind of appearance to the hair. And so up here you'll see a really nice smooth follicle, and then one that's flaky and damaged. And the older the hair is, because this is a permanent product that you're seeing, the older it is, the more that cuticle has been abused. And so this is really what products are trying to do. Kind of lay that cuticle down and make the hair smooth. So these are flexible strands produced by the hair follicle. Color is pigment from the melanocytes. And the amount of pigment, however, red hair, it really is a different pigment. And so they are really unique. It's real. And so the layers, rare. I mean, what's the percentage? What's the percentage of your flavor in the population? Isn't it? I mean, it's a low percentage, right?
I know red hair or blue eyes is less than 1%.
Yeah, it's a very specific combination, and it really is a different kind of pigmentation. 3 layers to the keratin shaft. And so in cross-section, there is the medulla, which may or may not be there in all hairs. It's that very core. But most of the hair itself is the cortex, very thick inner layer, and then of course the cuticle, which is a very thin sort of scale. But as that hair is produced within the hair, in the follicle shaft, you create these layers. The follicle is the gland that actually produces the hair. We'll look a bit at that. This picture seems complicated, but it had all the parts on it. So really what we want to do is see this papilla there. So that papilla is just a word that really means extension. So this would be the hair follicle papilla at the base. It's connective tissue with a capillary tuft so that you have a source of nutrient for the hair follicle. Or the hair follicle or bulb is the expanded portion that sits on top of this papilla. So you have this source of vasculature and then the bulb itself or the gland that will produce the hair. So it's going to be really very much like keratinocyte, the formation of the keratinocytes across the surface of the skin that builds up in layers, except that you have it in this arrangement so that you get something that builds like a hair is built. The hair bulb is this dilated terminus of the follicle. It houses the matrix. The matrix is the thing that will actually be the production of the hair follicle itself. There are keratinocytes with high mitotic growth as part of this matrix. So producing lots of keratin, and it slowly gets built upon itself. Melanocyte will uptake, the melanocyte produces the color and it gets uptaken by these keratinocytes right there at the base. There's a root sheath, which will be the sheath that creates the shaft. So above this hair bulb, you'll have the shaft with its two sheaths, an internal root sheath that is epithelial in nature, and an external root sheath that is connective tissue in nature to form the shaft. And the shape of the shaft determines the diameter of the hair, which makes a lot of sense. So this is like, cake decorating, like icing, and you have different tips that you can put, and so, you know, that will create a smaller or a larger piping that comes out. This hair shaft itself, that sheath, the shape of it, is acting as an extruder in a sense. So the matrix sits on top of the papilla. The matrix is making all the keratin. And the shaft is then just creating what is going to get the shape of what gets extruded then as the hair outside of the skin. And so the bigger the diameter, the bigger the hair. Finer hair would have a smaller diameter. A round diameter will create straight hairs. And the more oval or narrow the shape of that shaft is, then you get wavy or curly hairs. Isn't that cute? The way so that's just a sort of a genetic thing. The way that shaft is shaped is going to base what gets extruded from it. Ooh, that's so cute. And so you have these, so that should be pretty much genetic and pretty much lifelong. And then you see, so chemotherapeutic agents and alopecia-related hair loss from that is affecting this high rate of growth at this matrix. And that's why you have hair loss, because it isn't a constitutively produced thing. Like the skin in the gut is constantly being produced, but a hair only has a life cycle. That follicle has a life cycle. So if you kind of kill it during that phase of the life cycle, you have to wait till those next hairs regenerate. And so that's why you see this sort of specific hair loss. But additionally, often, or occasionally, I don't know if it's often, people's hair will regrow in it will look different. You'll see this or hear this, that, gosh, like my hair came in curly, you know, or something like that. So there's something about that process where the shaft gets changed in some people, I guess, when it regenerates. I'm not really sure about the process of that when somebody has gone through a hair loss or alopecia period, you might have something different coming back in, probably as a result of that. So just showing you the papilla here inside, which is just sort of adorably shaped, that you have this source of nutrients for this highly growing part or matrix around it, and the melanocytes producing their melanin and being uptaken by quickly the manufacturing of the matrix. And attached to that, you see this erector pili muscle and a sebaceous gland. So along the pathway here, before you have, at the end of the shaft, and then the hair is going to be attached at the root, and that's why it stays there. But you have the sebaceous gland, which will secrete oil into that, and into and onto that hair, and then also the erector pili muscle attached to that sheath. The hair growth cycle, 3 distinctive phases. The anagen phase is where the follicle lives most of its time. That's active growth and production of hair. So 90% of the life of that follicle will be spent there. And so how long that period is going to be based on where that hair is. And so if it's on the scalp, that anagen life is years. That's why hair can get long. But if it's somewhere else, that is weeks or months, which is handy, because then we don't have to get body haircuts. You know? And so that's cute. If it only grows for that long, then that's going to determine the length that hair could potentially be. And the rate of growth is about 1 centimeter a month, about a ½ inch a month for scalp hair, slower on other parts of the body. Eyelashes and eyebrows too, I forget about those, I guess. The catagen and telogen phase are much shorter, so more like days, weeks, you know, with a very limited part of that life, but it's where that growth will be terminated. So there really is just separation of like the papilla and closure of the matrix, and then some of that sheath will actually close down on the hair itself, and the follicle kind of dissipates. And so the catagen phase is the growth is slowing, and you'll have this sheath just really attaching to the hair. How do you detach that hair from that deal? You just kind of shut down that sheath around it, the extrusion shaft around it, and you can detach it from the matrix. So the telogen is when this, what we call the club hair now, can just be released. The bulb will shrink away, and so the hair can fall out. So you know that you have this cycle of turnover with hairs, and so that it's not all at once. Obviously, there's this efflux of hair and influx at all times, and so then the stage can start again. That follicle can start again. And for those hairs that are under the influence of hormones, you know, that's going to be that rate and return of hair will change over time. And certainly testosterone affects that. We see that postmenopausally, that changes hair distribution for women. And so definitely some follicles will be really under the influence of that as well. And then the little erector pili muscles. Do you remember what division of the autonomic nervous system? Full control here, sympathetic nervous system. This is a single innervation system. You don't have the parasympathetic system attached to the erector pili. And that little, I love this little cartoon here. So that little guy contracts, and it just erects that shaft. So it makes that hair stand up. And just that activity alone creates or generates some heat. Any work done will liberate heat. And then there should be, especially on any other mammal, that additional kind of air pocket that surrounds the skin for hairy mammals. Goosebumps. Nails. Lost a nail. Lost a nail. Lost a toenail. Runners lose toenails. I've lost a toenail. Extensive hiking that I've done. Wrong shoe. And you lose a nail, and it's so interesting if you have to watch that growth come back in, because the new nail will be under there. You think, oh, I'm going to have a bare nail bed, it's going to feel terrible. Obviously, you want the process to finish itself before that nail comes off. The nail comes off, comes away, loosens and goes, and there's something cruddy, but there's nail there. And it doesn't have a nice flat surface necessarily, but that'll grow on out. That'll look normal. So the way nails grow isn't just from the back, it's from the back and sides. So that's also called matrix. So just like in the hair, the most productive part, keratinocyte production is going to be at the matrix in the hair bulb. It's the matrix of the nail that is producing this claw. Nails or nail beds at the tip of the phalanges. You don't get to say that enough. Regina Phalange. Is that her name? Regina
Yes.
Phalange?
Yes.
Produces nails. It's a hard keratin plate. I was at an art class with a girl the other day, and she said something about the hell hole. I said, what is that? She said, where I work. I said, where do you work? She said, Pottery Barn. I said, Pottery Barn is the hell hole? She said, it really is. And I said, so does everybody love that Friends episode where Phoebe hates, she loves everything if she thinks it was a medieval apothecary, She goes, do you know, every time that airs, people come in and want the apothecary table? I'm like, it's 12 years ago, we don't still have it. Should come back around, reboot the apothecary table. That's a Friends reference. I'm sorry if you don't know what that is. So it's a hard keratin plate, and it's also kind of transparent. So when you don't have cells and nuclei and melanin in that, it's sheer. You can see through it. So why isn't hair sheer or clear? It's because it uptakes a certain amount of pigment or melanin. And so I think that's just so interesting that we do have these clear keratin plates, such that you can read a note you sat through it and tell something about the oxygenation of the skin underneath. So there are some specific things. The nail root is below the folds. The nail body is the visible plate. The free edge is what hangs over the fingertip, to whatever degree it does. And then the lunula is that moon-shaped part of the matrix that you can see. And the majority of the matrix will be under the nail fold. This is the nail, and here's the matrix is under here, but you can see some of it. Those keratinocytes still have their nuclei. So it isn't sheer to look through. Isn't it cute? Isn't that so, isn't that just so many cells that it actually becomes visible like that? So they're very dense and nucleated. And then here's a picture, you can see the flange. You can see that one phalange and the nail bed. And so this provides a lot of dexterity for being able to do stuff. And if you don't have nails, you can't do very much. My mother was so very ill in her last year of life. She was so undernourished, she lost all of her nails and all of her toenails. She certainly lost all of her hair. I even asked the hospice people, because her nails would just wake up and go, oh, Mother, honey, let's see which one is gone, And she lost all her nails, and she was so incredibly malnourished that they said, the hospice nurse was like, yeah, I don't really see that often. So it's just really a sign of that. It was just, so, but she couldn't do anything without her fingernails. So it's just, it's interesting how much, not just the fingertip, but that nail really allows us to just even be able to just to pick up things at all. And so, obviously, I don't underestimate my nails, but just really that it's such an integral part of our function that we're kind of lost without them. So anyway, lateral folds then are the folds of skin. So you see this picture, the folds of skin over the surface. So a whole bunch of the nail is back here. Nail matrix where the thing is being formed. So very much like a hair, except certainly you get this plate. And that's so interesting because you don't really, the nail fold is going to help produce or create that plate, but you don't have the same kind of extrusion that you do with the hair to create that shape. So it is kind of magical. But then when you see when the nail has been damaged and you get, you know, something is dropped on it and you see it keeps growing, but it uptakes that shape until you can have a reestablishment of the smooth surface. And so you'll see a lot of diagnoses where there is skin involvement, from eczema to certainly fungal kind of infections. But you can see if you have something underneath that nail bed, not very highly vascular, it's difficult to take, to do, it's underneath that nail bed, and topical treatments don't always do the trick and get there. The eponychium is this proximal fold over the edge of the nail body. So you see eponychium here is really this cuticle. Yeah. So your nail is going to be quite back behind that. And then the free edge is attached to a certain point, you know. When you get into that, that doesn't feel very good. So that's nail, and then I had been asked to add just some of these terms. You already went through these things, but it's kind of a natural place to go ahead and mention the different kinds of, remind you of the different kinds of lesions there are: abrasion, laceration, puncture, or surgical breach. So either induced or natural breaches to the skin surface. I guess avulsion is not there, probably would be a good word to add there. And then how you heal a wound, clotting phase, bleeding to the wound, you would expect that. A platelet plug, clotting factors to create cross-linking. So seal the leak is the first thing that will happen in the clotting phase. A thrombus forms or clot. And eventually that's the stuff that forms the scab. You know, the scab will be adherent while new tissue is forming underneath it. Don't pick your scabs. The inflammatory phase, then you have movement of inflammation. So movement of particles, of cells and fluids into the area, and you get all the classic signs of inflammation: heat, pain, redness, and edema. Those are good things. That means the process is working. When that inflammatory process is ongoing, then you tend to sometimes suspect an infection is there. But I always think, let stuff have a chance to heal, simmer down before you try to do anything to it, and then see how long it's going on. That's one of the first things you'll always ask is, well, how long has this been going on? It started this morning. Or 4 months. You're certainly going to react differently, I think. During the proliferative phase, then, you're just going to have tissue come in there that will do healing. So you get granulation tissue. So you'll hear about granulation tissue. And you specifically have a lot of fibroblast activity to create collagen, to create the particles that will help heal that. The granulation tissue kind of goes away. So you have to create structure and surface pretty quickly, and then that actually gets removed for more normal layering of tissue. So granulation tissue, if it went on, would continue to mount, and it wouldn't create a cohesive sort of repair to that surface. So the epithelial, so you have connective tissue come in and epithelialization over that, and then a retraction of that granulation tissue to create your epidermis and dermis layers. And then maturation would be that kind of shrinking back of the skin with any residual scarring that may be there. And it's maturation that takes a long time, and it is kind of itchy and people don't like it. You have to tell them that, you know, be patient with that because skin healing is a really long process. And then just the kinds of wounds, primary, a first intention means you close a wound in a clean wound. The second intention is the wound just heals without intervention in tertiary would be after it's healed, you kind of try to go back in there. And so the chance of infection is really the thing that you're worried about with closure. The wound has to be clean. But I was asked just to remind you of these. I think you've seen this. Will you do sewing in ER during the ER emergency medicine? You haven't seen them yet, so you'll do that during the emergency medicine. And you'll have these terms again and so forth. But cleaning the wound is a big deal because once you clean it, you have a greater possibility. It's that red pigment. It's causing you to have hiccups. I profiled you. Is ginger an insult, or is that a?
Depends on who you talk to.
Yeah, so I watch Bravo, and Andy Cohen always says, I love a ginger, and I'm thinking, well, that might be offensive. Anyway, you'll do sewing and so forth. That's kind of mention those terms during dermatology. So there it is, I believe. Do you have a lecture? I'm going to lecture at 11:30, but do you have